We're going to stop the recording until we get ready to go. Okay, we're back. Welcome, everybody. This is the CSINext October 2022 chapter meeting. I'm Mark Ogg, chapter president. Very happy to have everyone here today. Got a great presentation lined up for you. But before we get started, I just want to put out a quick thank you to our chapter sponsors, the American Woodworking Institute, National Gypsum Corporation, Northern Facades, ATIS, K-March Consultants. Without you guys, your continued involvement, your continued support in the chapter over the years, none of this would be possible with what we've been able to achieve. So thank you for your involvement. Thank you for your continued support. And for those of you that are interested in learning more about our sponsors, check out their web links on the CSINext.org homepage. With all the formalities out of the way, I would like to introduce to you our guest speaker today. That is Collette Hart from Allied Technical Sales. Collette, welcome, and the stage is all yours. So anytime you're ready to share the screen and get started, we're off and running.
Fantastic. Thank you so much, Mark, and the team here at CSI. Very excited to, quote, virtually fly out of Toronto, Ontario, and join you wherever you might be today. In the interest of being prompt and going ahead with everyone's day, I'm going to jump right into the presentation, but please feel free to use the chat. Mark, I'm going to ask, please interrupt me if anyone, pops some questions into the chat. Sure. I am pleased to be interrupted. I won't keep my eye on the chat, and then that way we're sort of good to go.
Yeah, and if anybody has got questions or anything, please put them in the, you should see a Q&A icon there at the bottom or on your screen. Just put that in there. That way it indicates I've got a question to go look at, and I can go there, look at it, and get the answer for you from Collette. So thank you for that, and all yours.
Okay, and just confirming, Mark, you can see full-size screen of my presentation. I didn't mess something up.
Yep, we're good to go.
Great. Okay, so you are here today to learn about designing a cost-effective Rainscreen facade with HPL. If you don't understand the term Rainscreen, please pop a note that, maybe you're a newbie to Rainscreen, and I can spend a bit more time on that. Also, if you don't know what the acronym HPL is, I will cover that as well. And it helps me a little bit understand the audience. If you don't know anything about these two terms, I will dive into that a little bit deeper. Okay, my name again is Collette Hart. I'm the North American Sales Manager at Allied Technical Sales. I did put in the chat, one of the websites where I work under is called Quick Ship Panels, and you'll find a lot of information there on how to reach me and hear more about these systems. I have represented lots of different Rainscreen products over the years. So if you are curious and want to learn more about different systems, I hope that you'd reach out to me on a personal, professional level. I'm gonna, put on my AIA hat and try and give you the most professional presentation that I can. If you need a certificate afterwards, I believe Mark will help coordinate that and we'll get that to you. Just make sure you follow up with one of us and we'll make sure to get you that certificate for your learning credits. Today's learning objectives, we're going to talk about what is HPL. I'm going to do a quick Rainscreen overview. Most importantly, what are the cost factors impacting all Rainscreen facade systems, but most specifically in regards to HPL, and then what are some awesome strategies on how to work forward. I, of course, know everyone wants quality up, speed up, results up, and the cost down. Everything in our everyday life is all about this, and it's no different with Rainscreen facades. Couple quick, beautiful images. This one is in China. This is Compact HPL in its sort of most interesting way. It's featuring a Core 10 steel finish without the mess of Core 10 steel, I will say, without the environmental challenges of Core 10 steel. So it looks phenomenal. It can be perforated in all kinds of curvy and fun shapes and backlit. And in this application, it's also a concealed fastener look, so you're not seeing any visible fasteners. This project is beautiful at daytime and nighttime. Here's two different metallic shades. Compact HPL is beautiful as a metallic finish. Some of the benefits, you can get large panel sizes that aren't going to dent, bend, oil can, and have various, detrimental features that sometimes are a negative on the metals. Again, we can do things with compact HPL that you can't do with some other materials. We can not only just cut curvy shapes into the panels, and the edges never need to be sealed or treated. So we've got nice round curvy lines on the face of the panel. As well, we can wrap the panel and bend it around some corners. Soffits, everyone's, you got to close in these buildings. So the soffit area is a great place, and we have a system that creates a closed joint here as well, and you get the benefits of that compact HPL in terms of its durability, its flatness, and various textures. Residential homes, also a great place. Most of us on this call, I'm assuming, are working in commercial applications, but if you've got some architects working in residential spaces, this is a great place as well. Compact HPL is made up of 70% paper and 30% resin, making this a phenomenal carbon neutral and or carbon positive product on your project. So all of the paper, it's basically craft paper rolled out in long strips, impregnated with a resin, and then compressed under high heat. Different manufacturers will have different processes and different decor surfaces. Ideally, you're looking for a manufacturer that owns that entire process, and both that they own their decor finishes, they're not buying those from a third party, and also that they own the pressing process. That they're not buying different pieces and laminating them together. You can then run into, as we all know, supply chain problems and color consistency problems. There are multiple applications of HPL, of high pressure laminate. You might be like, I don't know where I've seen this before. Trust me, you have seen it. If you have been in a toilet in a public space, you have seen it as a toilet partition, perhaps as a wall lining in an institutional building. Sometimes some lockers are made out of it. So in interior spaces, you've seen compact HPL as a countertop, as a wall lining. Laboratories and healthcare settings are great places due to the closed surface and easy cleanability. Today, we're going to focus on why and where it's great in exterior settings. Here's a big hospital in Fort McMurray, Alberta, very high-end sort of Canadian space here. Large format panels. These were all custom colored as well, and a nice vibrant blues with multiple panel shapes. This is the National Center for Civil and Human Rights. I have seen this, or started, I'm sorry, in Atlanta. Beautiful, and again, you're seeing some metallics, a little bit of a curved element, and this project has won many design awards, as we all like to be involved in the award-winning projects. Touching on Rainscreen, many years ago, buildings were built with one material. That one material was both the inside and outside of our building. And those could be various materials, from snow to rock to straw bales. People started saying, hey, I want some light in my building, so can I please have some windows? Well, now you've got to introduce two elements into your building facade. And then maybe they wanted something different on the inside of the wall and the outside of the wall. And we also wanted these inside spaces to be better insulated and consistent over time periods. This begins the development of Rainscreen. Rainscreen is as simple as understanding how a fly on a tent works. Anyone who has tented with young children and it rains, you basically want to ensure that you've got that fly over the tent that there is an airspace in between both the fly and the top of your tent, and that no one pokes that inside wall of the tent and you all get wet inside. The Norwegian barn builders were some of the first that we understand did this with their barns to keep their very expensive crops dry throughout the rainy season. So there was an interior wall, an airspace, and then an exterior cladding. And that's what we're going to talk about a little bit more in detail. There are many, many pictures. I am not proposing to show you the only one, but the RAINA Association, please bookmark this name or go Google them. The Rainscreen Association in North America is a newer association, and we are doing a lot to promote proper rain screens. One of the drawings that you will see is what we call the perfect wall. You have, from working from right to left in this diagram, the inside or your finished wall. That may be just a painted drywall, or this could be compact HPL. You may have some interior insulation. Then you have a support wall. You have a vapor control layer, a thermal control layer. We've got an air control layer and a water control layer. So there are a lot of properties happening in this tiny space. Very often these are with different manufacturers. So different specifications from my spec writers on the call. So you've got different specs, different materials that have different properties, and we all need these to operate in a harmonious way and ideally be installed by one trade, or at least let's minimize the number of trades that are having to touch these spaces. Then I want an unobstructed vertical airspace to create a nice chimney effect in here. And then I'm going to put a finish panel on here. This finish panel can be anything in the facade world of terracottas, fiber cements, aluminum or ACM panels, metal panels, premium metals, brick. And today we're going to talk that compact HPL goes in this space. Again, any questions, feel free to stop me, interrupt me. What influences the attachment? So the attachment of your facade panel to your substructure. Well, that's going to depend on the weight of your facade material that you've chosen. Compact HPL is around 2.2 pounds per square foot, putting it into the light or medium weight category, meaning your substructure doesn't need to be as robust as if you're hanging granite, which it could be a Rainscreen product, hanging granite off of your substructure. So we won't need as many robust clips here. So it's going to depend on the cladding weight, what's the wind pressure in your zone, depth of the system. This is going to be impacted by a few different factors, both the attachment method for that product, the facade product, how much insulation you require, what is the strength of that substrate. Is this a reclad and maybe we need to beef up something? Or is this new construction and we know the structural spacing that we can work off of? What's the backup wall construction type? And then what are the thermal resilience goals or requirements that we're trying to touch on? Are you trying to meet ASHRAE 90.1? Is this Passive House LEED certified? Do we have fire code regulations for the NFPA 285? These are all very important things. Also, are you working in a seismic zone? We may need to tighten up the spacing in those things. Okay, so those are a lot of factors, and I'm going to try and address a few more of them, but that's what's going to impact how you attach the system onto your wall. Cost factors. Here we go, getting into the money right away. So we're going to touch on what are the environmental cost factors, what are the panel selection cost factors, fixing systems, panel optimization, and then the install. Okay, these impact all facade products pretty much identically. So you're really just going to be then looking at what is my total budget for my wall, because these factors should be the same. Sustainability, our environmental cost factors cannot be ignored any longer. I hope that we are all trying to build sustainably now, and that means that we are building in a responsible manner so that the buildings can withstand higher changes to our climate in both high heat and cold temperatures, as well as severe weather incidents. This is a documentary. I encourage you to try and watch this. It's a great one. Basically, one house was left understanding an entire community because it was built both sustainably and in order to withstand climate change.
Collette, we got one question pop up
Mhm.
on carbon, and maybe you're getting it here. I know a couple of folks were at the conference last week in Denver, and there was a educational session on carbon embodiment in materials and sustainability. Are there?
Perfect timing for the question.
Right.
I hit the slide. Okay, so trees, while they're growing, and apologies if I am speaking at a base level for some people or over your heads, I'm trying to find a middle ground here, so I always start at the beginning. Trees, when they grow, they remove carbon or CO2 from the environment. They store that as dry mass, photosynthesis. I think a lot of us remember that word from young education. Compact HPL, the paper that's used in that production, the carbon remains captured in that wood, in that paper fiber for its lifetime, okay? So by choosing to use a paper-based or a wood-based product, you're already doing very good for the environment. So understanding that on this chart here that I pulled, there's a fantastic website, payette.com. They have a good tool, and there are lots of people coming out with new tools very quickly. Currently, this is my favorite, is Kaleidoscope, and they have an embodied carbon tool. You can play around. They've got lots of different calculators. The screenshot I have here for you, hopefully it's legible enough, but Rainscreen with a phenolic resin or a compact HPL panel rates very well in terms of using language. So less than my metric is off, 2 kilograms of carbon per square foot versus masonry or granite, which is tipping the scales at over 14 kilograms of carbon. So when you're choosing your material type for your facade, you may want to start to look at what is the embodied carbon in that material. And then various manufacturers have different programs in place where they, as part of their production process, maybe they're using hydroelectric energy versus coal energy. So you're wanting to partner with manufacturers that have a better environmental outlook in their production process. I've got one manufacturer that buses all of their staff in versus people driving in individual cars. So the carbon offset of that facility is much lower than some mined products per se. Okay, so I've tried to touch on it a little bit, and we'll maybe get a couple other points, but I agree, I really want to do another CEU way more on carbon and understanding it, and there are lots of resources, but I hopefully have directed you with Payette and their Kaleidoscope tool. Also in that same space, a lot of people are understanding that mass timber is a solution for building more sustainable buildings and reducing our carbon footprint because we're using actual wood and timber as part of the construction process. This is a project in Ontario around the corner from me. This is a college. It's also got Indigenous design. The exterior of the, the interior of the building is all timber framed. And then here we have our compact HPL panels in a black finish being installed on some aluminum, these are galvanized bars on this project, over top of some insulation for a very high performing wall, but you see they're still leaving the timbers exposed so that you get the beautiful aesthetic of that. The other reason compact HPL was chosen for this project, University of British Columbia, at the time, this was the tallest timber frame building in North America. They selected compact HPL in a wood grain finish, not a real wood grain, but a printed decor. Pardon me. Because there is zero maintenance required on this. So they wanted the look of real wood. You're getting the benefits of craft paper as part of the core material. And this timber frame building is then getting great LEED points and Passive House certification. And I visited this project earlier this year. It looks as beautiful as when it was installed 7 years ago. Okay. I know many of the architects and designers that we work with, or you are yourself, you have a box of crayons hiding under your desk because you like to build with vibrant colors. Compact HPL can meet your match there with your box of crayons, the various types of wood decors, natural materials like stones, and also metallic finishes, as I touched on. So Compact HPL has a wide range of not only just colors, but also surface decors. You can take that same panel and they can make a matte or a diffuse, a satin, a rock finish. So you can have one colored panel, but you could, some of them have panel orientation. So just by turning the panel, you'll get a change in color, which offers a lot of design freedom and also sustainable factors I'll touch on. Or you can get one colored panel with different surface textures and play around with light and darkness by using the same material. Panel thickness, this will impact your cost, as well as you want to use as little material or raw resources as possible for your application. So 8 millimeters or 5/16 is what I honestly do probably 90% of our projects with. 10 millimeters or 3/8 of an inch is required if we are doing a mechanically concealed fasten application. That is 20% more paper is required. 20% more paper costs 20% more. Okay, and then 1/2 inch panel. These are extremely robust. I'd probably use these where I know I have extreme high impact scenarios, signage or fencing, various applications. Very rarely do we go into that. 8 millimeters, I have 2 different attachment methods we'll touch on for that one. Panel sizes. Also, various manufacturers will have different panel sizes. This is really important to understand when architects and designers are doing their panel layout. Some manufacturers will just have one sheet size of a 4x8. Other manufacturers will have various sheet sizes, not only varying in width, but also varying in height. So you get a good mixture so that you can optimize your layout. You may also want to work with a manufacturer that has not only no minimum orders. I represent one manufacturer that you can order one blue panel if you would like and one wood grain panel. I don't have to order a full skid of material for you just to do this small area. That is a huge asset when it comes to your sustainability of the building. And then also, here is a huge money point. The top diagram shows what the architect wanted. They're like, I want panels about 100 inches and based on various layouts of mullions and other things. It worked out, oh, pardon me, got crazy with my mouse. 100 inches and a quarter with a joint spacing and the height of 72 and a quarter with a small joint reveal here. We said, hang on, Mr. Architect and installer, if we change your panel size by 1 inch, drop it down to 99, we saved them 30% in material cost. 30% is a huge number for just one little inch. So we went from a 6x12, which had a large amount of waste, down to using 6x8 sheets to get this great optimization. Was that clear for people in terms of how we go from taking sort of these various sheet sizes and saying, hey, on your crazy layout or on your very simple layout, let's work with the best sheet sizes or a mix of sheet sizes to get the least amount of waste. The least amount of waste is the true cost factor for all of us. Annual construction waste is expected to reach 2.5 billion tons by 2025. That is around the corner. All of us are hopefully here by 2025. So it starts right here in your waste hierarchy chart. You need to eliminate the waste in the first place. So that goes back to don't create the waste by having lots of offcuts. So let's eliminate it. Reduce the amount of waste that we produce. Reuse. So on your layout, Perhaps we have a small offcut. Well, where can we use that elsewhere on the building? So we want to take a panel optimization and move that around. Is the material recyclable? Unfortunately, compact HPL is not recyclable in North America. However, the product is so strong and stable, you can take it off of the building, and we have had clients build it into benches or swings at schoolyards. Okay, and then dispose of what's left in a responsible way. Okay, some of the benefits of HPL I'm going to touch on in the next few slides. So why do I think this is an awesome product for to use? One is the technology. There is a technology called electron beam curing. We can go into this deeply. It basically closes the top surface layer of the panel. This is a specifiable difference. So Mr. and Mrs. Spec writers on the calls, please encourage your clients, if they're looking at compact HPL, that they want something that has electron beam curing in that spec, because that closes that top surface layer. How that's going to benefit you? No dirt gets into that surface. No dirt means it stays clean, it lasts a long time. It's also UV stable. Here's a quick sneak peek, super fast, inside of a factory. This is a very automated, very controlled process on how compact HPL is made. I'll repeat it. I can't take you on a tour of the factory today, but this is how premium compact HPLs are made. Okay. Also, artificial weathering testing. Look at not only the material data sheet, but look at your manufacturer's warranties to see what will they warranty. I'm hoping that you're working with a manufacturer that's going to warranty the color fade to the highest standard, and that may be above and beyond the test standard. Maybe they're going to go with a Florida test cycle.
Collette? Yeah, got a question. Actually, my question on the warranty. Last week at the conference, I sat through a warranty presentation on roofing, and I learned more than a few things that I really didn't realize with a roof warranty. But in relation to once the material's installed and facilities under operation, what kind of preventive or ongoing facility type maintenance is required, or what depth, if any, is required for anything like this to help maintain the warranty? I know sometimes with roofs, there's certain things you have to do at certain integrals, and if you don't do it or can't provide proof that you did it, then they really get kind of stingy about whether something's quote warranty or not, if there's an issue.
Yeah. So I'm going to take the liberty, because I love questions. I'm going to skip down a section of the presentation. I just put this slide in today for you, Mark, because I think it's a really important topic. At the beginning, I touched on how compact HPL does not require any sealants or treatments when you cut the edge of the panel. So basically, we leave it raw, okay? Because no additional sealant or treatment has been required there, you don't need to maintain these panels. Compact HPL has one particular manufacturer has a standard 10-year warranty that requires zero maintenance. No maintenance is required to ensure that 10-year warranty. The other important factor when you want to look at warranties, where is that warranty adjudicated? If the product is made internationally, sometimes the manufacturers, that warranty is held in Spain or the Netherlands, and adjudicating that warranty gets very tricky. I represent a product that the warranty is held in North America by us. Okay, so that means you're really dealing with North American and US law. That is very important when you're trying to have a warranty claim. Okay. And I really encourage people to look at that. We've just created this slide, so I would love anyone's feedback. How I'm going to explain it to you, the blue bar down here right now is, pardon me, the slide does have a manufacturer's name on here, Trespa. This is compact HPL with two colors. We were preparing a slide for a client right now. They're trying to figure out what is the cost of ownership for this material over the 10-year life cycle. So blue line is both their compact HPL in a red and a wood grain finish. The yellow, they're like, well, maybe we'll just use half your material. So I'm going to use the compact HPL in the wood grain on this area and I'm going to put EIFS or stucco for anyone, on the red area. And then the green bar is going to show you what's the cost if the entire building was done in EIFS. We've automated this slide, and I think it's pretty powerful. The bottom toolbar, it's not showing. It is the cost of ownership. This bottom bar is at 10 years. What is the cost of ownership? Because on EIFS, you're going to have to repaint it, maintain it, maybe reseal it. But the Compact HPL, although it was more expensive at the beginning when we first installed it, over the 10 years, because of the additional cost factors on this particular project, it maintains the same $38,000 US dollars. The straight up EIFS went from being the lowest cost at the beginning. I'll show you the beginning slide again. It was the lowest cost to install, but then over the years, due to warranty, it changed. Is that kind of getting at the question that you asked, Mark?
Yes, perfect.
Okay. All right. Then I will jump back up. And we did do an entire presentation, and we built it a while ago on the cost of ownership. And that's exactly the point. Like, what does it cost to maintain this material? And I have to honestly say, Compact HPL, you put it up, zero maintenance is required. And honestly, if it gets dirty, you just clean it with whatever you would like. There are no special cleaners that are required. Little video. Oh, I don't have the audio, but this is an artificial weathering test, saltwater spray, Xeon arc lamp. They put all the colors in here. Any new colors that are developed are also tested to these same rigorous standards. Okay. This is a panel with the decorative or the EBC, the electron beam cured panels at 0 hours and 3,000 hours, zero fade, no change to the material. So you've got this great 10-year warranty. A melamine surface, melamine is a great material, not for an exterior application. So please, double check what type of surface layer is on there. After only 500 hours, it's got fade and white spotting and weathering. So compare your data sheet, but more importantly, like Mark pointed out, compare the warranties and what is required. Some manufacturers may not even share their warranty with you until you buy the product. That's my #1 red flag. If they won't share the warranty with you now, they're not confident in it. Other things to consider. So this product on the top left was not EBC cured. It faded so quickly that the screws actually maintained their color far better than the panel itself did. Here's what it was supposed to look like. This other project I've got, the client specified Compact HPL, the installer value engineered and put real wood up. Within 2 years, that real wood had faded out. It would have required owner maintenance to constantly go back, reseal and treat this. They said, I don't want to be sealing and treating that. They said, please go put up the Compact HPL like we asked, and it will look like this and maintain that. In all harsh climates, this product is installed high Arctic to Southern California. The other neat thing about Compact HPL, we often don't consider it when we're working on projects. Is this building going to expand or grow? Are they going to put an addition on it? This police station in Rotterdam did exactly that. After 23 years, they needed to put another small addition on. They wanted the exact same red colored panel. They could achieve that with this Compact HPL because the color has not changed in its formulation or its warranty. So brand new panels look exactly the same. You're like, okay, that's great if you're doing an addition on a building. What about if you build a small project and somebody drives into the building? It happens more than I can say as a manufacturer. We've built this beautiful facade, it goes up, but a few panels are damaged here. Replacement panels, again, you only need to order one panel from us. You don't need to keep attic stock anywhere because my die lots are going to be exactly the same. It won't be different from batch to batch. So So you can replace this one panel where, let's call this fatigued person drove right into the building. You can replace these panels quickly and efficiently and have the same color there. That's why it's important to choose a product that doesn't fade or change. Okay, going back into cost factors to the environment, carbon. I also want you to build straight buildings. Sometimes we're doing reclads. This is a very extreme example on a 200-year-old wooden barn, but we managed to get a very straight facade up by using, well, somebody might be on the call, but a thermal clip that's available on the market. This clip also offers adjustability for both vertical and horizontal alignment. And you can also do this in the same plane because you truly need to get this substrate straight. Then you're going to fill this cavity with insulation to improve that. You're going to save labor here. Labor is also where the money is at. So here's a simple detail to get a straight and thermally effective install with both large panels and small planks in various ways. Okay, exterior panels, getting a bit more into the cost factors. Big panels typically cost a little bit more sometimes. It depends on the thickness of the panels, but then it's going to be the attachment method. Plank systems are the new cost-effective way to do this. So this is getting into our fixing systems. Now that you've selected your rainbow bright colors, what you want to work with. So I'm going to go over 3 different attachment methods here. So this is taking my thinnest panel, an 8mm or 5/16 of an inch panel. So this is the one where I said we sell probably 90% of our stock. I'm going to show you a system of using it on an adjustable and thermally broken clip system with galvanized, both horizontal and vertical bars. You could do the exact, get the same aesthetic look of large panels, face fastened with color matched screws by using galvanized or wood battens. Wood battens would primarily be on residential, but some commercial buildings or people trying to get more sustainable may look at wood here. And then the traditional or the European way that many people saw was aluminum channels, or if you're in a very, very high salt concentration area, we might have to consider aluminum. Aluminum is very expensive. So let's look at some pricing comparisons. This is my chart, my panel cost factor. Let's use $1 per square foot. That's not how it works, but for simple math today, we're going to use $1 per square foot. Panel is the same across all of these. Adjustable and thermally broken, my first system here. My system cost factor, all of the subcomponents, is a little expensive. It's $105 per square foot. My install, don't forget the awesome labor that has to go into this. This is 0.75. Quickly scanning across the chart, this is the lowest labor rate because it's so fast to go put these clips up on the wall for a total installed cost factor of 0.85. An aluminum system, this one on my bottom right, is at a cost factor of 1.0. So if we added all this up, I'd be at $3 per square foot here. I'd be at $2.85 here. I am saving money just by going with the superior adjustable thermally broken. But guess what? I'm also getting the super bonus points of meeting new energy efficiency codes, and I am fire code compliant for NFPA 285. Huge factors. Okay, the next system, some of your architects may say, no, I do not want to see those screws at all. I want a mechanically concealed fasten. As I said at the beginning, this is now 10mm thick, so my panel is thicker. That is more expensive right there. Then we have to use aluminum clips and rails on the back of the panel. These aluminum parts have to be extruded. There's no cheaper way to get those. Then I can go back to our galvanized clips and verticals. Okay, this is a mix of galvanized steel and aluminum channels, or if I'm using both aluminum. Okay, yes, you can achieve some really cool looks, no visible fasteners. I hope your client has a big budget for this one though. My panel cost has gone up by 20%. System cost factor. My system cost factor is, again, it's going to be high here with my adjustable thermally broken clip, my install cost factor stays the lowest. Oh, pardon me. So I'm getting a total cost factor. So my on the wall cost is less by using an adjustable and thermally broken clip system. You also, again, get the great benefit of meeting your energy codes and staying NFPA 285 compliant. The last system I'm going to show you is going back to using a thin 5/16 or 8mm panel where it's been fabricated as a tongue and groove system. So this is going to notch together with a much smaller mechanical clip. So we're still fastening this with a mechanical fastener, not using an adhesive. It could be simply installed on wood strapping, a small clip, and then the panel is fastened in here. You're getting long lengths and runs. You're getting the benefit of a closed joint here, whereas with this type of system, this is going to be open joint between the panels unless we add an additional joint closure on, which would further increase the price. I should add that into my presentation. So this is benefit of a closed joint and a thinner panel. Watch what happens to our pricing strategy here. So this is an example of the building. We've installed both these vertical panels that are about 2 feet wide, very long length. I can go up to 14 feet in length. I can also do small panels in that same plank application. So you're getting a multi-height plank system installed in the same manner. You can install it both vertically and horizontally. So understanding this, your panel cost factor is pretty much the same. If we've got very small planks, it may go up a little bit. Have I got a question coming in?
Yeah, Collette, on installation, is there like a manufacturer, is there like a training program or a certification program that folks that are going to be installing this, they could go be trained on the install?
Yes. So different manufacturers will have, and this ties back to the warranty, they may require a trained installer. So that can be something that goes in a specification as well, that you have to have completed the manufacturer's training course. At my company, I have 2 full-time trainers on staff who can do both virtual. Because of COVID, we ended up doing a lot of virtual training sessions and got very good at those. So they are basically around North America doing an installer training session, or they will go to site for large projects. Also going back to the RAINA Association, the Rainscreen Association in North America is trying to come up with some standardized testing for everyone doing Rainscreen, because there are some fundamental facts that we want everyone doing Rainscreen in the same way. Understanding that you need a vertical airspace behind the panels to let the panels move, be ventilated, etc. So both through RAINA, there are upcoming training courses, and different manufacturers may require that as a warranty thing. Great point.
Okay. And from a, say if you're doing a LEED type facility or a certified type facility, is there any specific commissioning requirements? Say you're doing enhanced commissioning. I know this is on the outside of the building. Is it involved with, would it be involved with any of the building envelope or enclosure commissioning testing that is required? I know that's kind of, it's state to state, locale to locale, what's required in that aspect.
Yeah, I have been involved with those, Mark, when they've been part of a weather testing system where maybe it's combined with the curtain wall prior to install. They'll maybe do a weather test on the entire assembly, where maybe we're mixing it in, like on the University of British Columbia, the photo earlier, it showed the entire wall being installed in a unitized method. That would have had some weather testing performed prior to assembly. I'm not aware that Compact HPL, none of the manufacturers I'm aware of have that as a requirement for install. Different products on the market may require that. I am not aware for any commissioning. The product, once it's up, it doesn't move, it doesn't do anything. It's pretty inert.
Okay.
Okay. So then understanding this plank system, our panel cost factor, pretty consistent. The system cost factor, this is where it goes really low. It's our lowest cost factor because it's just that little aluminum clip. The cost factor to install it is much less. So we get a total cost factor of getting a mechanically concealed fixed, closed joint, long linear plank look, a total cost factor of 1.26 versus my one here, 1.68. So as a comparison, you're getting a very comparable look with a lower cost. You can get, various plank heights, maybe not as big as some of the mechanically, so we will need to look at plank height. You may not always meet the energy codes here, so we will have to watch that. So it depends on your building. An NFPA 285, I can now change this to yes, this plank system does meet the NFPA 285 for fire code for large planks with a galvanized steel substrate. Okay. Specifiers, before I lose your attention with 15 minutes to go, please reach out to myself or jump on our website. There are specs that you can download. I've tried to make it as easy as possible for you. I am happy to receive your specs back, and I'll help maybe highlight or make some suggestions for you in terms of warranty, performance-based, panel sizing, install methods, okay? So let's try and get the right system specified up front so that we don't have to rework it during the bidding process. This is a project I like to do a quick case study on. The architect originally designed it with big rectangles with mechanically concealed fasten. We re-optimized this building for a bit more of a long linear plank look. Cost factors, I'm just going to go through this super fast. Basically, the original aluminum substructure system, panel optimization was at 75%, so I was throwing 25% of the panels in the garbage. With a new optimization, we got the panel optimization up to 87%, so far superior in our use of panels. For a total material, so both substructure and materials, a cost savings of 50%. Then I added in 50% faster labor, and we got the ownership a great install. Couple last points, corners and trims, something that's sometimes overlooked. This system, Compact HPL, does not require corners, but sometimes in a high impact area, you may want this. So we can detail it as an open joint system. But if you are concerned, maybe at a bank, a walkway, or a school corner, you might want a little bit of protection. There are various ways to do this with corners. Okay. Also, your shop fabrication, if we can fabricate most of it in the shop, we're going to save field labor. Also, how is it getting shipped to site, and is it protected? And make sure that your manufacturer sends you all your screws and clips at the same time. So you want to work with a fabricator that understands your shipping and logistics. Cost factor, who's absorbing and figuring out? People call me all the time and they're like, Collette, how much is this project going to cost? And I was like, where in the world is it? Is it hanging off a cliff in the Maritimes? Is it in a seismic area, hot, cold, downtown city? So, helping to understand your full project scope and who's carrying what for the equipment and labors. My last sort of design triangle, criteria for selecting material. I think it's pretty much the same whether you're buying a car or a fridge. What do you use to select material? Well, what is the function of the material? Do I need, large format panels? Do I want them UV, scratch resistant, impact resistant? What code requirements am I being required to meet? Do I need to meet NFPA 285? What maintenance and testing? Hopefully you're like, I don't want anything I have to maintain. Collette showed me that one chart. I want a zero maintenance product so that I have the full warranty. And if you have specific testing requirements, let us know and we'll find out if we have that for you. Then when you're selecting a material, the aesthetics. Maybe you want a wood grain look or you want a metallic look. What do you want it to look like? Do you want long linear planks? Do you want it open joint, closed joint? What's the fastener spacing going to look like? And then the cost. Here we go. The big thing that we talked about. What is the cost to acquire your material? That's also your material, fabrication costs, and labor to install it. What's your environmental cost? Let's get smarter about this. What is the environmental cost both to embodied carbon, the life cycle assessment of the product, and also, you know, do you have to maintain it or throw it in the garbage in 5 years because it's a throwaway product? And then what's your operational costs? As Mark touched on, do I need to do anything to replace or maintain this product? Okay, I did show this chart. I'm going to try and leave you guys with 10 minutes left if we can. Quick strategy. How can you help your architects, designers, and ownership groups? Well, what's the color? There could be differences based on color and finish. What's the thickness of the panel? Maybe we can thin it out and go to a 5/16 versus a thicker panel. And what's the finish? Do you want a shiny metallic or a more matte look? There could be some price differences there. Is fire code a requirement that can increase the cost factor? So if you don't need to meet an FPA 285, I can maybe make some changes to the system. Work with a supplier who's going to minimize the waste. Don't ship extra panels across the oceans if you don't have to, and also don't throw extra material in the garbage. Maybe we can create renderings or do a panel optimization for you as part of the design process, and then work with someone who understands the labor costs as well. That's it. I hopefully explained to you today what is Compact HPL, a high pressure laminate. We learned a little bit more about Rainscreen. We touched on a lot of cost factors, and now you've got some strategies to take to your ownership group. I can send you also this summary sheet at the end, which sort of goes over a couple of the terms. That's it. I'm done. Pepper me with questions, or you can share screen and show me a project you're working on. Okay. Any additional questions from the audience?
Hey, Collette. I've got a couple in here that just rolled in. As we get up towards the end of the hour here, we'll see if we can get these couple answered, and I think we'll call it a wrap. Great topic, great information, very informative. I did not know there was this much involved in things that I've seen out in the field. So this was definitely good information for me. BIM elements are architectural BIM elements available from you guys direct? Is it through, maybe like one of the websites, BIM Object or something like that? Are there Revit, AutoCAD, all that kind of stuff? Do you have those available for your products?
We do have them for both the product and the attachment methods on the Quick Ship Panels website that I initially put in the chat. I apologize, my company, someone put it behind the wall where you have to just put in your email address. I promise we will not spam you or mail that to, Roger's loading house and you'll get spammed with tons of stuff, or just reach out to me directly. I can send you the CAD details. Yes, we do have BIM and Revit available. We tend to get more involved with those project specific though. Otherwise we find people just use them willy-nilly. So we'd like to be involved in that design process.
Okay. The kind of like the question of the day now on every topic, as far as what you've seen with supply chain lead times, how is that? I know some of the components here being plastics and resins and stuff. I know that stuff is not easy to get. What kind of impacts have you guys seen on your end? And let's just say for like a typical project, that case study you used, the Carl's Jr. What would typical lead times on that material be once everybody approves the submittal in the shops and said, this is what we want? Okay,
so I've got two great ways to answer that. Lead times in Europe at the production facilities have greatly improved throughout the course of COVID, and we are back to where we like them. Production time for a brand new order is about 8 to 10 weeks. That's our sort of standard, so that's pretty good. We're happy with that. The company I work for, Allied Technical Sales, and our Quick Ship Panels, we understand that there are sometimes smaller projects and various other projects where either you're short a couple panels or you need something faster. We invested years ago. So even before COVID and supply chain problems, I'm carrying about 80,000 square feet of inventory right now, not allocated to a project. So if you would like to work with what we consider some of the most popular colors, oh, let's see, they're black, white, gray, red, and then a couple wood grains. I have that in stock and I can fabricate that quickly and get it to your job site. We work with a lot of CIDs, or I call those corporate identity clients. So Carl's Jr.'s, Bye Bye Baby, Bed Bath, Nathan's, Sporting Life. We maintain inventory for some of those clients so we can quickly turn their material over for them and get it to them in 2 to 3 weeks. So I've got two scenarios. One, the better news coming from Europe from the factory, things have improved to 8 to 10 weeks. If you have a small project or you're working with a client on a repeat basis, we can hold inventory for them like we did for this sales office. And they use the same colors over and over again.
Okay, great. Great. Well, I've gotten a lot of good feedback in my little chat box here. Great.
Okay.
Collette, I think that finishes up our questions
Yes, right on time. Well done.
and such. Time, everybody can get to their next one, right? And folks, you'll be should receive a survey at the end of this as being an attendee. It should have an option on there if you need to have your AIA credit verified. Please check that, and we will make sure that everybody gets that taken care of. So CSINext November meeting will be, I believe, on November 10th. We will be hearing from chapter member and secretary Thad Goodman from National Gypsum on area separation walls. And we will have that invite out shortly. I believe it may be on the CSI Resources website, and we will be posting it shortly to the CSINext.org website. So again, Collette, thank you for joining us. Great topic, great information. Everyone, have a safe rest of the week, and we will see you in November. Thanks.
I know. Thank you.